This is Algebra 1, Unit 6, Lesson 5, Compound Inequalities. So first of all, what is a compound inequality? A compound inequality is an equality that combines two simple inequalities together. We know how to do that. So for example, say we have x is less than 3 or x can be more than 5. Either of those two situations make the statement true. So say for example, your mother says you need to clean your room or do the dishes. If you do either of those two situations, you're good. Okay, so right here, number 4 is not a solution for this compound inequality. So if you walked your dog, you wouldn't satisfy the two possible conditions. Then there can be an and. This is a compound inequality where both of the conditions need to be true in order for it to be correct. In this case, when you graph it, you're looking for the two spots where they overlap. So in this case, the number has to be more than 0 and it has to be less than 4. Okay, so in this case, 2 is a solution, but 5 is not. Okay, all right. What you can do is you can just rename this for that section that's highlighted here, right here. You can put x in the middle and you can say it has to be more than 0, but it has to be less than 4. So you can combine, instead of writing two statements with an and between them, you can just combine it into one. All right, here, let's practice. We're going to start with an or, and we're going to start with our two-step inequalities. We know how to do this. So the first thing you want to do is let's get rid of that 3. So we're going to subtract 3 from each side. So you get 2x is greater than or equal to 4. Divide each side by 2. So it looks like x has to be greater than or equal to positive 2. So let's go ahead and graph that. It's greater than or equal to 2. So we're going to make that a solid circle and we're going to shade to the right greater than. Let's try the next one. Subtract 9 from each side. And we get 2. Divide each side by 2. We get x is greater than 1. Okay, so it's an open circle because there's no bar, and we're going to shade to the right. So this is one of the cases where we don't need both of those. The x is greater than 1 took care of the other one. So when we write our final answer, always we have to say is x has to be greater than 1. It took care of the other inequality. Let's try another one. So we're going to subtract 1 from each side. So we're going to subtract 1 from each side. So we get n is less than or equal to negative 4. So let's go ahead and graph that. Less than or equal to negative 4. So we have a closed circle on negative 4 and we shade to the left. And let's try the second part. We're going to divide each side by negative 4. We know when we divide by a negative number, we have to flip that sign. So in this case, n has to be greater than 2. So we put an open circle and we shade to the right. Okay, so in this case, we don't want to combine those together because they're not overlapping. So we're just going to use that as an or statement. All right, let's try an and. So in this case, we're just looking for the overlapping section. They both have to be true. So we're going to add 50 to both sides. We're going to divide by a negative 7. As soon as I see I'm dividing by a negative, I'm going to flip that sign so I don't forget. And I get negative 7. So x needs to be greater than negative 7. Oops, so that's down here somewhere. 4, 5, 6, 7. Okay, so we want a closed circle on negative 7, and we're going to shade to the right. Okay, let's try the second half. We're going to subtract 72 from, or 70 from each side. So we get negative 6x is greater than negative 72. divide each side by -6. Again, I'm dividing by a negative, so I don't forget. I'm going to go ahead and flip that sign. And what's that look like? Positive 12. So x has to be less than positive 12. I didn't pick a very good line here. We're going to say this is 12. And I put an open circle and I shade to the left. So in this case, we just want the section that's overlapping. Okay, this is an and situation. So I'm going to go ahead and combine them together. So I put my x in the middle. I put my less than symbols here. So it has to be greater than -7. In this case, it was a closed circle, so I'm going to put a bar there. And it has to be less than 12. And there's no bar, so I'm going to leave that as an open circle there. And this is our solution. As long as x is greater than or equal to -7 and less than 12, that's in our solution. Here we go again. Uh-oh, they already combined it together for us, like we did in the end. Okay? What you could do is you could split it into two. Let me show you what that looks like. You could say 6 is less than or equal to x plus 6, and x plus 6 is less than or equal to 11. If you don't like it written this way, you can rewrite it. You can flip it. Just remember, when you flip it, you flip the sign also. Okay? And solve them separately, just like we did on the last one, and combine them together. But there's an easier way. Okay? Why make extra work by splitting them? What I would do is I would just, whatever you do to one side, you do to the other. So in this case, we need to subtract 6. So we're going to subtract it from both sides. Okay, so there we go. We get x, we get 0, and we get 5. Okay, so boom, it's done already. Isn't that easy? Okay, so what we want to do is we want to put a closed circle on 0. We want to put a closed circle on positive 5, and we're going to shade between them. It's all done for us. Okay, if we had to divide, say there was a 2 here, we would divide both sides by 2. Whatever you do to one side, you have to do to the other side. Very easy. Okay, there are a couple special cases. You probably knew this was coming. So let's go ahead and see what that looks like. We're going to add 39 to both sides. Oops. What's that? -4. Divide each side by 4. So it looks like x is greater than -1. No problem there. Put an open circle on -1, and it needs to be greater than. It's pointing to the right. And let's try the other one. And both of these have to be true. We want to see where our two graphs overlap. So I'm going to subtract 31 from each side. 8 looks like 8. 8x. Oops, that's a -8. Okay. So then we're going to divide by positive 8. So we get x, that's a negative, is less than -1. So again, we'd have an open circle on -1, and this time we're shading to the left. Okay, this is an and, so remember both of them have to be true in order for it to be a solution to our compound inequality. Obviously, there's no number that's going to be less than -1 and greater than -1. So if you see something like this, we say there are no solution. And let's look at the last situation. So in this case, we're going to do it to both sides, or we're going to subtract 2. Here we go. So I want n is greater than -9. Again, I didn't choose a very good one. 5, 6, 7, 8, 9. Here we go. Open circle, shade to the right. Okay. And on the second one, I want to divide by -4. We're dividing by a negative. Oops. So you know we need to flip the sign, and that gives us a +5. And so we want n to be less than +5. So we have an open circle on +5, and we shade to the left. So we look at our graph, and either of these two situations would make a true statement. So you can see our whole number line is filled in. So in this case, we would say all real numbers. So that means every possible number is going to work for us. So if your whole graph is shaded in, you say all real numbers. If nothing is overlapping in this case, you say no solution. Please try the practice problems. Let me know if you have any questions. Thank you.